Okay, moving on. I am coming to the realization that I have way too many of the infinite geo formula problems on this last worksheet. Sorry about that. Oh well. But now we get some finite geoseries these are finite. They're all geo still, but they're not infinite anymore. But this one just asks, let me fix that from fading like that. This just asks which is that series. So which of these has a first term of 2/3 and a last term of 256 over 6,561? So I'm going to look at the first terms first. Let's see, the first term here would be when n is 1, and 2 to the first is 2. So the first term, let me call it A for the first term. The first term would be 2 over 3, right? This first term is when n is 1. And that first term would still be 2 over 3. This first term, though, is when n is 0. So this first term would be 1. And this is another, we're starting at 0. So this first term would be 1, not 2/3. So these two are out. So now I go to the last term. It's either the 9th or the 8th term, right? So, so all I really need to do is worry about the 2. 2 to the 9th, is 2 to the 9th 256, or is 2 to the 8th 256? So I know 2 to the 5th is 32. So 2 to the 6th is 64. 2 to the 7th would be double that, so 128. And 2 to the 8th would be 256. So 2 to the 8th is the one that we want for our last term. Okay. Number 26. All right, back to our infinite sums. This is an infinite sum. It must be geo, otherwise we wouldn't be able to find the sum. FYI, in calculus we'll be able to find sums of some that are not geometric, infinite series that are not geometric. But for this year, for right now, this must be geometric. So what is the common ratio? What are we multiplying by each time? It's alternating in sign, so I know r will be negative. And what do you multiply 27 by to get 81? A 3. What do you multiply 4 by to get 16? A 4. So r must be a negative 3/4 here. We could check that by multiplying 12 times a negative 3/4. Do you get a negative 9? 4 goes into 12 3 times. 3 times 3 is 9. It's negative. So yes, it does check. So r is a negative 3/4. The first term is 12. So first term over 1 minus r, multiply top and bottom by a 4. 48 on top over 4 plus 3 on the bottom, so 48 over 7a. Alrighty. Number 27. Which is true about this series? Okay, the series has a sum of negative 8, diverges, sum of 8, common ratio of 2/3. Okay, which of the following is true? Well, I see that these terms are getting bigger. And if the terms are getting bigger, that series will diverge, definitely. There is no way that we can get that to converge if the terms are getting bigger, right? If you added larger and larger terms forever, would that ever converge to be a single number? No. This would be geo, but r is bigger than 1. Okay. An infinite geo series has a sum of 14, common ratio a half. What is the first term? First term over 1 minus r is equal to 14. 1 minus a half is a half. Multiply both sides by a half. 14 times a half is 7. The first term is 7. Find the value of this. It's infinite, geo, r is between negative 1 and 1, so the first term over 1 minus r. The first term is when n is 2, so put 2 in for n. We get a 1 there. 2 times a fourth is a half, so the first term is a half. R is 1/4. 1/2 over 1 minus 1/4. Top and bottom by a 4. On top we get a 2. 4 minus 1 on the bottom, 2/3. An infinite geoseries has a sum of 11. The first term is 7. What is the common ratio? First term over 1 minus r is equal to 11. Multiply both sides by 1 minus r. 11 minus 11r. Subtract 11 on both sides. R is 4 over 11. Okay, what is the value of this? It is arithmetic. Arithmetic. And so sum of an arithmetic would be n times the average of the first and the last terms. So the first and the last over 2. What is the first? How many terms are there? How many terms are there? 30 minus 0 plus 1 gives you how many terms there are. There are 31 terms. Okay. The first term is when n is 0. So the first term is negative 10. The last term is when n is 30. So 90 minus 10 is 80. So we have 31 times 70 over 2. 70 over 2 is 35. I'm going to need to come off to the side and multiply this out. $1085, so D is the correct answer. I do like having multiple choices for some of these problems just to confirm what I'm doing. Alrighty, order the following from least to greatest. Each of these is arithmetic, and they're all finite, so we're going to be finding some sums here. Alright, so I'm using the number of terms. N is the number of terms. How many terms are there? Top minus bottom plus 1. So top minus bottom would be 14 plus 1 is 15. The first term is when n is 11. So 22 minus 25 is a negative 3. The last term is when n is 25. 50 minus 25 is 25 over 2. Just need to simplify this. 15 over 25 minus 3 is 22. 15 times 11. Do you know the little trick for multiplying by 11s? Multiplying a 2-digit number by 11, take the 1 and the 5, split them up, add them together. It works every time. 1 and the 5, split them together, split them apart, and then add them together. So if you had 23 times 11, 2, 3, 5, 253. Cute little trick. Alrighty, 165 there. So over here, how many terms? 15 minus 0 plus 1. So there are 16 terms. The first term is when n is 0, so the first term is negative 10. The last term is when n is 15. 45 minus 10 is 35. So we get 16 times. This is 25 over 2. I would reduce the 2 and the 16 to make 8. 8 times 25. 8 times 25 is 200. 8 25s. Last one here. Okay, how many terms? 20 minus 3 is 17, plus 1 is 18, so we have 18 terms. The first term is when n is 3. 30 minus 6 is 24. The last term is when n is 20. 30 minus 40 is a negative 10. So we have 18 times 14 over 2. 18 times 7, which is 56. Carry the 5, 126. Okay, so again, from least to greatest, what is the least? 126 is the least. What is the next? Number 1 is the next, and the last is number 2. So 312. 312 is B. B. How are we doing on time? I'm going to keep on going. Okay, which of the following is true? Okay, every infinite geoseries with common ratio r and first term a has this sum. No. R must be greater. R must be between -1 and 1. It must be. So that is not true. To determine the sum of a finite geoseries, you must know the last term. The sum of a finite geoseries starts with the first term, 1 minus r to the n over 1 minus r. Nowhere in there is the last term. So no, you do not need to know the last term for a finite geoseries. You do need the last term for a finite arithmetic series. Every infinite arithmetic series diverges. That is true, because the terms are either going to keep on getting bigger and bigger and bigger, or they're going to be all negative, but their magnitude is getting bigger and bigger and bigger. So that is true. D, no series can be both arithmetic and geometric. Remember back early on I think on page 1, we had one that was both arithmetic and geometric. If I have 9 plus 9 plus 9 plus 9 plus 9 plus ... that would be arithmetic because you're adding 0 each time, but it would also be geometric because you're multiplying by 1 each time. So that is false as well. So the answer there would be C. Write an explicit formula for this sequence. Okay. This is not arithmetic, nor is it geometric. So I need to come up with the pattern on my own, and I'm thinking, gosh, what is it, you guys? Oh, my goodness. Sometimes I can see these really fast, and sometimes I just don't. Oh, 1 cubed. Oh, this is, I'm going to see if this works. That is 1 cubed minus 1. This is 2 cubed minus 1. This is 3 cubed minus 1. This is 4 cubed minus 1. That is 5 cubed minus 1. So the formula would be n cubed minus 1. Let's write an explicit formula for this one. Let's see, what is the pattern this time, you guys? Oh, goodness. Is it similar? Is it 1 squared plus 2? 2 squared plus 2 would be 6. 3 squared plus 2 would be 11. 4 squared is 16 plus 2 is 18. 5 squared is 25 plus 2 is 27. 6 squared is 36 plus 2 is 38. Yes. So it would be n squared plus 2. So those work. Now there might be others that work, but I know that those work. It says an explicit formula, not the explicit formula. So maybe there's another one that works. I don't know. Okay. Here, this is 12 times 11 times 10 times 9. Everything else reduces with that 8 factorial. Divided by 4 times 3 times 2 times 1. And now I'm going to clean this up. Okay. Blot that a little bit. 4 times 3 is 12. Reduces with that 12. 2 goes into 10 5 times. So let's see. I have 99 times 5. 99 times 5. 9 times 5 is 45. 45. Carry the 4. 45 plus 4 is 49. So 495 would be that expression simplified. For this one, I start with my biggest. My biggest is the n plus 1. This would be n plus 1 times the next number down. The next number down from that is an n. The next number down from n is n minus 1. The next number down from that is n minus 2, and it would keep on going, right? I'm just copying down the bottom. These are going to reduce, the n is going to reduce, and I'm left with n plus 1 times n minus 1, d. Okay, for this one, which is bigger? The bottom is bigger, so I'm going to start down there. 2n plus 1 times 1, this minus 1, and this minus 1 is 2n factorial. I'm stopping there because of what I see on the top. These are going to reduce. We're left with 1 over 2n plus 1, b. Where are we at? Okay, I'm going to pause. One final video coming up.